Okay, we start. Good morning, everybody. First of all, I want to acknowledge the presence of the speakers in this session and also everyone for their interest in it. I'll make a short presentation because we only have 5 minutes for a speaker, and then after their presentation is the time for questions from the audience. Okay, the energy usage has a special relevance in the field of smart cities, but also present enormous opportunities to incorporate new technologies and systems adapted to a new way of thinking about cities. Bring closer power generation to consumption, incorporate renewable energy sources locally, incorporating intelligence to networks in order to optimize the consumption, and, for example, maximize the number of electrical vehicles integrated in these networks. To develop intelligent systems capable of storing energy or new systems until now not being taken into consideration, like take advantage of residual energy sources. From the point of view of the consumption patterns, there is also a long way to go. It's not just turning off the lights, it's also providing information to the consumer in real time and incorporate systems that enable and facilitate the consumer to change his habits, enabling citizens to move from only consumers to consumers, producers, and managers of their energy. Technology has a key role in these changes, but also the regulation and the local authorities, which should be one of the motors of that facilitates this transformation. In this session, we'll have examples of all of this. We have 7 different proposals related to energy in smart cities: communication for lighting, logistic and transportation, integration of solar PV and solar thermal in buildings, an example of participation of the local administration in the energy renovation buildings, and a company that provides systems that help people to improve their energy efficiency. We began the presentations then, and we start with Antonio Royo. Antonio Royo is founder, CEO of the electronic service companies UVAX, and Antonio has 30 years of experience in electronic industry as R&D engineer. He's a Bachelor of Science in Electrical Engineering in Winter School of Engineering, master's degree in electrical engineering in the University of Valencia, and holds several degrees in Berkeley University. Please, Mr. Antonio Royo. It's your time. Okay. I think they. Okay.
¿Tengo que darle otra vez o ya arranca? Okay, at least it doesn't count down. That's why I ask myself, why is Microsoft so rich? It never works. Where is it? Plus or here? Now it works? Great. Okay. Fine. Good morning, everyone. Thank you for your time. My name is Antonio Royo. The first time I heard the expression smart cities, I asked myself, what are smart cities all about? And if you ask today 1,000 experts, they will probably give you 2,000 different answers. But in one single issue, they agree, everyone agrees on, is that cities are facing today huge challenges, and mainly because of the growth that they are facing today. So if you look at the most important task that a city has to take care of is planning, services such as healthcare and education, and also infrastructures. And the infrastructures, we can divide it into 3 blocks: transportation, water, and energy. Energy being probably the most important one, because without energy, everything else breaks down. So energy has to be actually what cities, if they grow, are very concerned about. Otherwise, cities are not going to be sustainable. And sustainability is definitely one of the big issues today. Okay. Now let's look at how has the energy sector changed in the past 40 years. And Denmark is an excellent example. You can download these great pictures from the internet. And if you look at this, in 1985, there were only or less than 30 decentralized power plants. Today there are over 1,000. And wind turbines, there were less than 100. Today they have more than 5,000. So that means the whole power grid has changed quite a bit. Okay? And the only way to cope with that is with smart grids. And cities are the most important factor within this smart grid. And they have to deal somehow in a smart way with the energy consumption. So let's look at the basics of smart energy. What does that mean? On one side, what we want is low cost. That means it has to be cheap energy. But we definitely want also that it is sustainable and it should be environmentally friendly. And the only way today to approach this is doing a good work in energy efficiency. But you can only do good energy efficiency if you have data and information. And that information should be in real time, because that's the only way you can react and then also predict, to use then the smart analytics and see how you can use this information and be more energy efficient. So the focus is definitely going to be in real time. That's essential. Okay. Now, if you talk about data and information in the energy sectors, a big part of it is smart meters, because they are the ones measuring and getting all the readings and the information about the habits in the energy consumption. So real time is important, but before we go deeper into the smart meter sector, let's see what's happening in the industry right now or worldwide with the information exchange. And they are pretty impressive. Today, we have more than 1 billion queries at Google every day. More than 250 pictures are moved through Facebook every day. Twitter has more than 290 updates every day, and so on. Now, if you take now real-time information from smart meters, that means we are going to have 15-minute readings. So this is going to add an additional 96 billion, readings every day to the whole information that we are going to transfer. Because what we expect in the next 10 years is that there will be at least 1 billion new smart meters worldwide. So, and that's why experts predict that from 2010 till 2020, the information exchange worldwide will increase by 31 times, which is amazing. We are talking here about 35 zettabytes, and the zettabyte is real big data, because that's a number with 21 zeros. Okay. Good. So if you're going back to the smart meters, how are we going to cope with this information flow, which is going to be great and amazing? So definitely not with narrowband, because narrowband is today's technology, but it's not going to cope with the future demands. That's why we have to go to broadband. Broadband is essential, and this is a great picture that CPA, after a very intensive study, came out with, that unless you have broadband, you won't be able, to have actually a TCP/IP interface, which is actually essential to have cloud-based solutions. So that's why we developed at UVAX a broadband communication systems for energy efficiency applications in cities. But not just for cities, it can be also used in the private sector, for industry and for private homes. With that, actually, and getting real time, people have information so that they can really save energy. It doesn't help you if you get a one-time readings a day later. because if you get today what you wasted yesterday, you cannot do anything else about it. But if you get real-time information, then definitely you can react and prevent waste of energy. And the same thing for cities. We have developed an application called PADI, which stands for Prime Administration and Dynamic Handling of Energy. What that does is actually it's based on outdoor lighting infrastructures, and I'm going to be finished very soon. It's based on outdoor lighting infrastructures. That means street lights. And what that helps is actually putting in cities a broadband communication network based on power lines used for street lights to add a lot of additional features, such like a fast charging station for electric cars, video camera surveillance systems, Wi-Fi access points, and so on. Because the most important thing is that with broadband, you give actually a very important tool to cities to have the most important thing, which will be demand response and in real time, and that's what actually future smart cities will have to do to be real smart. Thank you. ¿Preguntas luego? Vale.
Thank you very much, Mr. Royo. Now is the time for Stefano Persi, co-founder and CEO of the energy firm ENIDE. Stefano has been involved for many years in research and innovation in transport and logistics sector, especially in the field of green vehicles and supply chain. Please, Mr. Persi.
Okay, so unlucky. I try to stick very much with the guidelines they gave me, so no more than 4 slides and 4 minutes. Let's see if I manage to keep the time. Basically, first of all, what is ENIDE is a company focusing on research and innovation, mainly innovation, and bringing innovative technologies in transport. But we try not to bring technology because we like the technology, but like to bring solutions that we can use. Here we have an example, then I'm working on other things, but today we're talking about unplugged. So a solution is inductive charging for electric vehicles. I was here at EVS 27, the symposium of electric vehicle, and if you go over there, you can see similar solutions are more close to that we think. So this is a just project. I don't know if you're familiar with this, but it's basically the European Commission pay research of a group of companies, university, research center, working together for a solution that is a bit too complex for just one company to work on. So we see like some of the major companies, to give us some example, names that you can know better than others, for instance, Enel, Endesa, Fiat, Volvo, Transport for London, so the City of London, and Renault, and so on and so forth. Renault is in the advisory board, is not in the project, but they're all collaborating in a way or another one. So why all these companies are focusing on this solution? What is special about this, and why the Commission is like giving us something about 2.5 million to work on this project? Is it really necessary, or do we just plug our cars by cable, like we all seen so far? And are this vehicle like really coming into the city? Because that's another big question. Like we have a big symposium about electric vehicles. Are they really coming? Are the people buying these vehicles? And I think one thing I would like to make, an assumption I would like to take away from the people's mind, I think is already clear in people's minds, is like people are not there dying to buy electric cars. Electric cars is a good solution, they're sustainable, they are better than current cars, but we need to have a good vehicle that can be used, and they can be economically interesting, they can be easy to use, and they can be as good, at least, as the current vehicles. So we talk about sustainability a lot, and we think, okay, the city has to be more sustainable. But the focus for me is the people. The first thing that the people think when they take any decision is, I want to think what is the best solution for me. So if the electric vehicle, they are not good enough, they're not going to use it. So if we want to promote the electric vehicles, we need to progress on the engine, on all the technology that make it better, on the batteries and so on, all the problem we know about. But we need to take care to make the solution as smooth as possible. So if we think to some technology we use like the iPhone, it's not like just overloaded of complex technology. Obviously it's there, but it's very nice to use. So is it nice to use an electric vehicle when it's raining? We need to charge it with the cable is dirty. We need to handle like high power in our hands. Do we like do this? Probably not. So there are many other problems, but this is one of the problems we need to improve. On the other side, like we're thinking about this solution for parking as well as traffic light. You can charge a vehicle that is waiting on the traffic light, or a bus at the end terminus or the terminus when you go in. So this whole technology, you cannot put long cables while the car is running. This is not feasible. So in some cases it's obvious, in some cases it's not so necessary, but will make it much better. And the main purpose is also reducing the battery. If you charge it more often, you have a lighter battery. For a vehicle like a bus, it's mandatory because you don't want to carry batteries, you want to carry people. So the interoperability is the main challenge open in this field. The technology is, you can go to DVS and there are already solutions there. Prototypes more or less close to the market. But when we think to a solution, we need to have all the solutions working together. We need to be able to charge a light-duty vehicle and a car, perhaps a bus in another area, but we need to charge all of them, no matter which car manufacturer they are from, no matter which country they come from, because it could be a DHL or somebody that move their vehicle fleet from a country to another one, and they have to work all together, and all the billing and so on, no matter where we charge them. Only this will make the electric vehicle a reality in the close future. So thanks, and for more questions, I'm available later. Thank you.
Thank you very much, Stefano. Now is the time for Antoni Orti. Antoni Orti is an entrepreneur and co-founder of OTEM 2000, Green and Management Solutions. It's a company specialized in local generation of clean energy through different technologies and innovative solutions as energy floors, solar floors, hybrid energy floors, and smart floors. The presentation is Sustainable Cities, Motion is Energy. Antonio?
Hola, buenos días. Soy Antoni Orti y soy el Project Manager de OTEM 2000, una empresa que promueve la generación local de energía a través de innovadoras tecnologías basadas en energías renovables no convencionales. Bien, como todos saben, las ciudades de hoy serán las que sufrirán las principales dificultades de este siglo XXI. El cambio climático, el aumento de la población y su traslado a las ciudades, el aumento de la demanda de energía y el empeoramiento de la calidad de vida de los ciudadanos. Pero también es cierto que sabemos que las ciudades del futuro deberán asumir el reto de dar solución a estas dificultades invirtiendo en innovación y tecnología, energías renovables, eficiencia energética y la movilidad sostenible. Desde OTEM 2000 queremos contribuir a que estas ciudades consigan este reto a través del concepto Enercity. Nosotros generaremos energía en la ciudad para el consumo en la ciudad, a través de tecnologías innovadoras que se basan en el aprovechamiento del sol, del movimiento de las personas y de los vehículos para generar energía localmente, para dar valor al suelo, a los edificios y a las infraestructuras, para así que las ciudades sean más competitivas. El primer grupo de estas tecnologías que presentaremos serán los Energy Floors. Son tecnologías activas que necesitan ser pisadas bien por personas o bien por vehículos para generar energía. Para el caso de las personas, OTEM 2000 lo que hace es transformarlas en pequeños microgeneradores, aprovechando su movimiento. Estarían pensados estos dispositivos para estar instalados en zonas de alto tráfico, ya sean en aeropuertos, estaciones de metro, estaciones de tren o incluso en calles comerciales. Pero también tenemos soluciones para aprovechar el movimiento de los vehículos, como podría ser transformar una carretera y aprovechar ese movimiento, ese vehículo, para transformarla en una energy road. O también, como es este caso de un paso de peatones, que aprovecha el movimiento del tráfico de las personas y también de los vehículos, insertando en este caso materiales piezoeléctricos en el asfalto. Otra familia podría ser los solar floors. Estas son soluciones pasivas que aprovechan el sol para generar energía. No deja de ser tecnología fotovoltaica transitable. Este sería el modelo diseñado por OTEN 2000, el cual puede estar instalado bien sea en cubiertas planas, en patios de colegio, en plazas públicas, o hasta incluso podríamos instalarlo en un carril bici y transformar el carril bici en un carril bici solar para poder cargar las bicicletas. Otra solución sería la Building Integrated Photovoltaic, la integración perfecta de la energía solar a los edificios. Podríamos encontrarlo bien sea en muros cortina, en fachadas ventiladas o también, como es este caso, en una claraboya semitransparente. Bueno, también es decir que para OTEN 2000 es importante la generación, pero también lo más importante cómo gestionamos de una manera eficiente esa energía generada. Nosotros también lo hacemos desde el suelo, usando esta tecnología llamada los Smart Floors. No dejan de ser dispositivos autónomos que generan la energía necesaria para tú enviar la señal desde el suelo al elemento que tú estás gobernando con el movimiento de las personas. Este, por ejemplo, sería un ejemplo de cómo podemos gestionar los servicios de un edificio, ya sea el sistema de ventilación o el alumbrado, hasta incluso la seguridad o detectar la ocupación real mediante este sistema. Es comunicación desde el suelo vía radio, pero también podemos enviar a la nube datos bien sea de ocupación para aplicaciones en temas de bibliotecas para saber la real ocupación. Bien, con todas estas soluciones que hemos presentado, OTEN 2000 lo que quiere es ayudar a cumplir el objetivo marcado dentro del Horizonte 2020, como por ejemplo sería el caso de los edificios públicos, para que estos sean cada vez más autosuficientes. Y comentarles para finalizar que durante el próximo año en la ciudad de Martorell, próxima a Barcelona, vamos a realizar una prueba piloto de nuestra tecnología de Solar Floors, donde vamos a poder demostrar cómo podemos generar energía limpia para poder dar luz a una plaza pública mediante estos sistemas. También mencionar que el concepto de Energy City, tal como se ha comentado también a través de otros speakers, hay otras maneras también de implicar a la ciudadanía. Nosotros, desde OTEN 2000, lo que lo hacemos implicando a la ciudadanía generando energía limpia y también igualmente dando valor o aprovechando el movimiento de los vehículos, que tal como se está comentando, de los vehículos eléctricos, pues poder generar energía y poder cerrar el círculo real de cero consumo en emisiones de CO2 y también en la generación aprovechando el tráfico de todos estos vehículos que en un futuro circularán por las ciudades. Bueno, muchísimas gracias por estar aquí y bueno, si necesitan cualquier consulta, pues muy amablemente se lo responderá.
Gracias, Antonio. The next speaker is Mr. Misara from Fraunhofer IWES. He's trained as electrical engineering at the University of Hanover. Mr. Sinara joined Fraunhofer IWES as a researcher in 2006, and he's also a member of the ERA Smart Cities initiative and has been involved in several projects in the field of PV system technology and building integration. The presentation title is Greening Energy Positive Tool for Smart Facilities. Please, Mr.
Okay. This one, right? Okay. So good morning, everybody. So let me introduce myself first. I am Siwanand Misara. I'm a researcher at Fraunhofer IWES in Germany. Today, I would like to give you, let's say, a short overview about the greening energy positive tools for smart facility. I know that we have heard a lot about city. Somehow it's quite big for us, maybe some of us cannot understand how is that possible, right? And today I will give you a short overview. I will make it smaller, not in the city level, but in the facility level, which we have, let's say, 7, 8 buildings together, and how can we make it smarter? And in this case, we will provide you, I will show you, let's say, the tools that for the decision maker, for the facility manager, on which size and how to make them smarter. And that is, let's say, one of the research project beams from the EU. And that is, let's say, the first concept, beams. And as I told you, I will show you facility, and that is, let's say, the picture we have. You will see that we have all kinds of road, right, like HVAC lighting or whatever. And we also have facility manager or city manager or somehow like this. But on the other hand, we also have utility. How can we combine with them? And that is, let's say, the basic architecture we have in project. And you will see that to communicate to all of them, we put, let's say, Ojima, which is, let's say, the open gateway energy management to communicate with the load, with the facility manager, and at the same time to utility. But for the research focus, what we have done here is the self-consumption. How we can, let's say, increase our self-consumption in our facility. In this project, we have, let's say, PV, which is, let's say, the main resources of this facility. And we have also the load that we have on demand load, which is, let's say, the lighting that you cannot postpone them. And also the postponable load, which is, let's say, somehow like the storage. We have the HVAC system. HVAC system is, let's say, somehow like the thermal storage, and electro vehicle, which is electrical storage. And that is, let's say, what we have done in this project. We have developed the decision support tool for facility manager to decide which size of the PV, which size of the battery is, let's say, the most useful for our facility. Not only in terms of the technical point of view, but also in terms of economic point of view. And it will be run by facility manager. That is, let's say, the basic concept that we have on the facility level. What do we need for these tools? We need power production profile, which you can get, let's say, from the historic data, and also the load profile that you can also get from the load historic data as well. In this case, you can get from the historic or also from the simulation base. And that is, let's say, the example that we take from one facility in order to run the tools. You will see that we have the electrical load from the different buildings and public use as well, and also the thermal load, which is, let's say, the HVAC load. And afterwards, we also need, let's say, the PV system configuration. What does it mean in this case? Let's say like inflation or size of the cost, and also the feed-in tariff. And in our research point of view, in the latest slide, I will show you, okay, what happens if we don't even have any feed-in tariff? Does it make sense? What size of the PV is, let's say, more useful for me? And we have done in 3 scenarios: direct compensation without any storage, or existing thermal storage, which we are talking about the HVAC, and also the existing thermal and electrical storage together, which I include, let's say, the electrical storage battery or somehow like this. That is, let's say, the first figures that I would like to show you on the technical point of view. You will see that the self-consumption from the load point of view. You see that once you increase the peak of the PV, of course, the percentage from the load side, for instance, you have 100% load. You install 5 megawatt system for this facility, you can have around 19% that can covered by PV. And it starts to be saturated somehow due to the power consumption during the day and during the night. And therefore, it doesn't make sense anymore to increase the PV. But on the load side, from the PV side, once you have 5 megawatt, right? That means all of your PV will be consumed in your facility. But once you increase the size, you cannot use it anymore. You can use just only, for instance, 20% at 20 megawatt, and the rest, 80% will be fed into the grid. And that is, let's say, from the technical point of view. The next graph will be from the economic point of view. I take example from Spain, which, let's say, the electricity price is around 11.6. You will see that storage doesn't make sense at all, right, with this condition. Therefore, for this facility, I don't even need the storage with additional investment. Therefore, the PV at around 17 megawatt is, let's say, the most economic for this facility. But if you see in Italian with other price, you will see that the NPV or the economic become increased to 30 millions, and the gap between the storage become closer. What does it mean? It means storage become, let's say, will play a major role later on, right? Last figure I show you once, we have 24 cents. This curve is quite very interesting. You will see that NPV of the battery is much higher than without battery in this case. All of this, I want to show you only different contexts. In Germany, in Italian, in Spain, in Singapore, or whatever, the decision maker will be completely different based on different contexts, right? And it is very important for facility managers to design what size of the PV do we need, and also the type of the storage and the size of the storage as well. And afterwards, once you do compensate with electrical and also the load, the residual load profile, you can use them to bargain with the energy purchaser in order to have, let's say, a cheaper price for your electricity bill. And that's all from my side. Thanks a lot.
Thank you, Mr. Misara. Very interested result. Now is the time for Mr. Jan Schabert from Germany. He was born in Munich in 1967 and studied civil engineering and architecture at Stuttgart University and Entrepreneurial University in Munich, TUM. He founded his own architecture office in 1999 and has been teacher and researcher in various European countries. He will present his presentation is about solar energy, collecting masonry modules. Please.
So does this microphone work? Can we have this microphone, please? 1, 2, 3, 4, 5. Fantastic. How do I do this? Good morning, ladies and gentlemen. My name is Jan Schabert. I'm an architect. The keynote which we saw yesterday from Kent Larson, he was addressing that architects are so restricted in what they can do. They cannot but combine different systems. And I completely disagree on that. So what I want to do, and what I think is essential for architects to do, is to play with these systems and not to be working for the industry, selling their products, but inventing or changing products. And that's what I want to do. What we see on this slide is, you can see it as good or bad. This is pumping energy. We got bricks. I was researching on bricks. We got a brick facade and some machines who are pumping in energy or out or whatever. But using some kinds of fossil fuels maybe. And then we get, I could see that as, I think there's a lot of mileage in that, in using this facade to pump in and pump out some energy. On the positive side, we have here fantastic in Germany. We insulate our buildings with big insulation material, which is like saying to the environment, we don't like you, we don't like the environment which we have out there, so stay out, we don't want you in. This should be really separated. So maybe it's not so fantastic after all. So I was trying to look into this brick and see if we can use this brick somewhere, maybe look really inside and see what it can do if we turn it inside out, this brick. So if we have this brick not being an insulator, separating the inside and the outside, but trying to bring in some what the sun gives to us. At EKWC in the Netherlands, European Ceramic Work Center, I was developing and trying with several ways to how could a brick do something more, pay back what has been put into them, the fossil fuels which have been put into them to fire them. And so I came to this approach not to defend from sunlight and stay out with lots of insulation, but love the sun and let the sun in and try to do some heating and try to do some cooling too. And we do that not with high technology, but with this termite technology, where they can cool their buildings like that. So I developed this brick here, which can, if we see that, this is the outside, obviously. We got the sun on the outside of this facade, and we got cavities. Okay. We got these cavities behind the surface, the outside surface. And in these cavities, the air is heating up, and it wants to go up, but it can go up, so it has to go up in this diagonal way. and towards the inner surface of the outside wall, which is heating up by that strategy. And if we want to control that, if we don't want to have it's too warm and we don't want to have too much heating in this building, and this is what if you have this insulation, it's always insulated day and night and summer and winter. And if we have that, want to change that, maybe we can have some simple flap which is opening on the top of the wall, which is like air through or not air through. And then we have, if we close that on top, then the air is like stalling in there and it is not moving, it's not transporting any energy anymore. So we got an insulating wall. We tested that in several different ways. We got an alternative also, which is like sucking in air through the foundation and bringing it up if you want to cool the inside of your building. So that should be working as well. A picture of the simulation. And then the next issue would be, because it's a small module for an urban module to create fantastic cities, how to produce them in bulk masses. So we're working on that and see if we can, press mold these bricks, like you do that with roof tiles, and that has been working in this small prototype. So this is how it works. So far we are at this stage at the development point of having this idea, but the industry, which is like expecting us as architects to follow them and to ask for their products and just buy the products, has not bought yet the product of ours. So they are staying with their products and are happy with this insulating strategy which they have so far. So let's see if we can get some brick industry to produce this wonderful brick and save the planet. Thank you very much.
Now is the time for Andreas Jaadla from Estonia. He's Director of Development and Education in the Rakvere Smart House Competence Center. Mr. Jaadla, as Mayor of Rakvere City, has been the initiator of the European Covenant of Mayors in Estonia. He has been Vice President of the Union of the Baltic Cities from 2009 to 2012, and member of the EU Committee of Regions from 2002 to 2012. He holds a Master of Law by the University of Tartu. And he will present the Rakvere Smart House European Covenant of Mayors. Please.
Thank you, everybody, for this possibility to participate in this World Congress here in Barcelona. And I speak a little more about politics. We speak in this conference about how we can change the cities for the smart cities. And I bring for you example from one small Estonian city, name is Rakvere. I'm here a lot of slides, but I'm quite quick running, like you picture so. And as you can see what we are doing with the last 5-6 years to change the city profile, to promote the city, to invest to Rakvere. Rakvere is maybe nobody know here in southern part of Europe. This is a small city in Estonia, 100 kilometers east from Tallinn, our capital, and 100 east kilometers to the border of Russia. We have quite old city, more like almost 1,000 years old, 700-year city rights. And Estonia generally is a very small country, and we have the seven largest or 9th largest city in Estonia, but this means approximately 17,000 inhabitants, like in Europe is not so big city, can we say town. What we are doing and how we can change this, our city profile with last 2 years. Here is some facts about Rakvere more. And about myself, I've been mayor of city of Rakvere 10 years, working quite actively in the internationally and the Europe level. And we started at changing with continued government of mayors initiative of European Commission in 2008. 2008 European Commission invited together all males to say that we must save CO2 till 2020, 20%. And Rakvere, one of first of them who signed the Covenant of Mayors 2009, and already in the same year we are making the own city SAP, Sustainable Energy Action Plan. This means we in the political level, in the city council, we making decisions. We must invest in the 6 key goals, that is district heating, heat consumption, water consumption, urban transport, street lighting and city planning. And we're making quite concrete plan to how what we can do and invite investment for such kind of activities. In 2008, all street lights in Rakvere and public building use green energy that's produced not in fossil fuel. We have 2009, we have taking sustainable city general plan, how we can develop city in the sustainable way. Here is like exception, we are making energy audit for all buildings, public buildings in Rakvere, and here you see how in 2008, you see the last one is music school, how much this concrete building use energy. After then we making audit, you see this music school before, and here after renovation in 2009. This is big changing, and we measure the energy every time, and you see here how this energy using is going down in these last years. Some other project we have our other Soviet time building. We want to build like low energy consumption school, Rakvere Elementary School, and this building is ready in the next year. Now we have financing. This is the process already going on. So the other things we are thinking how the people himself living in housing cooperatives, the big buildings, how the people can save energy himself. You see this one region in Rakvere where lives approximately 70% of inhabitants of city, and we make a plan for the street and invite in this process not only city planners, but the people who lives in the housing cooperatives, change the view of the street and same time insulate the building. This is 16 housing cooperatives, and we're together making plan. Here see how much inhabitants this have, and we are making plan how we can change this not very nice looking Soviet time buildings. Here you see the two famous persons, some ideas how the buildings can look in the future. Some guys from Rakvere who is now in Japan making sumo wrestling, and the other is world famous compositor Arvo Pärt, who is from our city. And here you've seen the works of architecture. And the other big project what I lead now, I'm not anymore mayor, is Rakvere Smart House. This is Smart House Competence Center in Estonia, who promote all smart solutions from Estonia to other cities. This is like we want to in future be in the center of intelligent urban space in Estonia and Rakvere. Here we organized, here see old building and new buildings, how this architectural competition are finished. Here is coming a lot of pictures. But this old building are really very old, and here you can see picture about, I think, 18 years ago. This Rakvere is like small village, and you compare what with 100 years, how much the Europe and the world is changing. Started on small cities, go to the bigger one. 33, this building already. This is part of our center today. 2003, we renovated Central Square here in the before the building. Now the picture we can see so. And 2015 must be ready the new part outside of the old building, the Competence Center in Rakvere. And this is the first public narrow city building in Estonia. We totally make the plan for architects using this BIM. This was for us really very big work. Here is coming some picture more how the house can see in the future. 2015, after the building is ready, and you can very welcome to visit Rakvere there. Here's some pictures. My time is now running. 5 minutes is for especially for the politicians. We can talk with hours here. But here is some picture I just running. We have one of the 60 centers. And the other things, what I must say, maybe on 1 minute extra time, you must, if you have some small city, you must quite strong promote this city in Europe, and we have been quite active of them. We have member of the Smart Cities Council. We have a lot of project doing. Coming my final slide, we have one of the candidate of 2010 European Sustainable Energy Awards, Copenhagen Summit, meet with some important people in Europe. The front page is Covenant of Mayor 2011 with 6,000, 3,000 cities in Europe, meet in Germany. Here a lot of meetings here you can see, but I want to see the solutions. With results coming with 6 years work, we are becoming 47 million euros for such kind of small city. The city budget overall is 11 million a year. 3-year budget we are becoming to use in such concept of 2009, the Sustainable Energy Action Plan and this one. And we make audit in 2012 how much we have saved CO2 with this year, with this 4 years. And you know the self-process is surprising 48% with 5 years, making so clear plan how we can change the profile of city. So, thank you, and when we in Rakvere say every large thing smart or these small matters. Thank you very much.
Thank you very much, Mr. Jaadla, and congratulations for these initiatives. Now is the last speaker, Mr. Armando Florencia Suay from Spain. He's from energy manager from Xial Domotecnología. Mr. Florencia is industrial energy, specialized in heating and air conditioning system, energy efficiency and renewable energy. His career is focused on looking for efficient and intelligent buildings. He was at Xial's home automation technology as energy manager and helping customers to save energy. Please, Mr. Florencia.
Buenos días a todos. Como bien ha comentado la moderadora, mi nombre es Armando Florencia, actualmente soy Energy Manager en Xial Domotecnología y a continuación, estos próximos 4 o 5 minutos, les voy a intentar explicar brevemente lo que es Xial y sobre todo lo que es Energy. Xial Domotecnología comenzó su actividad en el año 2008. En principio, nuestro trabajo se centró en el sector residencial, tratando de apostar y de encontrar y de tratar de que estos edificios fueran lo más eficientes desde el punto de vista energético y aportarles inteligencia. Fruto del trabajo de nuestro equipo multidisciplinar nació Energy, nuestra plataforma web on cloud para la gestión energética de viviendas y edificios. Energy destaca en este ámbito como una potente herramienta de gestión y control a tiempo real que cuenta con toda la información energética del edificio. Da servicio, por un lado, al cliente o al vecino, permitiéndole controlar su vivienda, al mismo tiempo que gestiona y controla su gasto energético, intentando mejorarlo, como así como a todo el círculo energético, lo que nosotros denominamos el resto del círculo energético del edificio, ¿no? Lo que serían una serie de profesionales como pueden ser las empresas de servicios energéticos, administradores de fincas, mantenedores, suministradores, instaladores. Realmente, ¿qué es lo que hace a Energy una plataforma on cloud que la haga única y diferencial? Pues en primer lugar, como acabo de comentar, se trata de una herramienta que da servicio a todos los agentes implicados en el consumo del edificio, desde el vecino hasta la empresa de servicios energéticos. Se trata de una herramienta multidireccionalidad, que es multidireccional, donde no solo recibimos información de todos los, podemos tener contadores volumétricos, contadores de energía, contadores de energía térmica, eléctrica, sino que además nosotros también aportamos información a esta plataforma. Además, aportamos transparencia al mercado. Energy permite que todos los usuarios dispongan de la información energética a tiempo real, lo cual es muy importante, porque hasta ahora, como bien sabemos, muchas veces recibimos la información, si va todo bien, de forma mensual, ¿no? Además, como consecuencia de ser la cabeza de un sistema abierto, Energy permite la incorporación de múltiples servicios ajenos a Xial. Además, obviamente, tiene que ser un coste accesible. fue uno de los primeros hándicaps que tuvimos a la hora de meternos en el sector residencial, ¿de acuerdo? Porque teníamos que hacer que esta plataforma tuviera un coste accesible para todo vecino. Un factor muy importante y diferencial es la inteligencia, con el cual conseguimos que Energy piense por nosotros, ayudándonos a ahorrar y a mejorar nuestro confort. Y por último, y no por ello menos importante, tenemos el factor de seguridad. Sabemos que estamos trabajando con datos que son pues, muy delicados, ¿no? Son datos de consumo, datos que nos tienen que facilitar los usuarios y, por tanto, tenemos que contar con las máximas garantías de seguridad. Todos nuestros datos están almacenados en un data center con las máximas garantías de seguridad. Contamos con un SOC, un Security Operation Center, vigilancia 24 horas al día, 7 días a la semana, backups continuos y muchas otras. Pero pronto nos dimos cuenta que para llegar a nuestro sueño de la Smart City hacían falta 3 cosas más. La primera era desarrollar Energy para nuevos sectores, como pueden ser el terciario, los temas de hoteles, sector retail y además en el sector industrial. Además de dotar a las aplicaciones que ya teníamos desarrolladas en Energy de la mayor inteligencia posible. Esto quiere decir que sin ningún tipo de intervención humana directa consigamos a nuestros clientes el mayor confort y calidad de vida, ahorrando cada día un poco más. Y, por supuesto, incorporar a Energy aplicaciones externas a ellas, pero obviamente complementarias. En el momento actual, los nuevos módulos de Energy para distintos sectores ya son una realidad. También muchas aplicaciones inteligentes, como la que nos permite que el sistema de calefacción de una vivienda sepa cuándo activarse automáticamente, o la que recomienda qué estrategia de consumo seguir para conseguir un objetivo marcado de consumo energético. Seguimos trabajando para tener algunas otras aplicaciones nuevas muy potentes, como por ejemplo en el sector hotelero, como la que recomienda a los hoteles qué habitación asignar primero debido a cuáles son las que consumen menos energía, debido a su orientación y otros factores. En cuanto a las aplicaciones externas que podemos integrar, como por ejemplo, como hemos comentado, cámaras de seguridad, gestión de stocks, bases de datos, continuamente se hacen pequeñas mejoras de hardware y software en Energy para poder incorporarlas e interconectarlas, de forma que Energy pueda ser esa herramienta única para la gestión de la Smart City. Como ven, la de Xial es una tecnología que aporta 2 de las necesidades básicas hoy en día, como son calidad de vida y ahorro. Muchas gracias por su atención.